Hey everyone, my name is Neil Aryan. Today we're going to be talking about SNS SQS and additional compute services beyond EC2. Now, if you want to learn more about EC2, the links to those videos will be in the description. There's the two videos that I made before this one. And without any further ado, let's jump into this video. So before we talk about SNS SQS, let's talk about monolithic architecture, which is a form of virtual architecture which is most commonly found, in which different components of the application are tightly coupled and are highly dependent on one another. Now, these components may only work together if they're all in sync, if they're all working at the same time on the same thing. But if one component lags behind, all the other components need to lag behind until the one that first slowed down catches up. Now, this is not what we want. What we want is decoupled architecture, which is a type of architecture in which one internal slowdown doesn't mean everything else needs to slow down. This reduces interdependencies, and this also makes us fault tolerant, which means that if there's one issue arising in one certain area, that doesn't destroy the entire architecture and the application can still run smoothly. It's also sometimes referred to as a loosely coupled architecture, but they're interchangeable. Now, a monolithic approach looks something like this. There's a component one just directly sends data to component two, hoping that component two will process the data. But component one doesn't know if component two is finished with what it's currently doing and if it's able to get more information or if it's able to process new information. If it's not able to process new information, the data won't go through. The data might get lost, or component one won't be able to send more data and it'll have to be slowed down because of component two. Now, a decoupled approach introduces a buffer in which component one will send information to the buffer, and when component two is ready, it will take information out of the buffer. And that introduces a decoupled architecture because now component one is not dependent on the speed of component two. They're only dependent on their own speeds. Now let's talk about messaging. Messaging between endpoints in applications allows us to create buffers so that we can have a decoupled architecture. Now, two of the services that are used to create this are SNS and SQS, which is simple notification service and simple queue service. Now, simple notification service is pretty easy. It's just a service in which the publisher sends messages to subscribers. And this could be used by a team member by relaying a message that a certain task needs to get done, or that they've completed a certain task and they're ready to move on to the next task. Now, someone in a different department may be communicating with them and they need to go back and forth, and that's what SNS can be used for. Subscribers could be anyone, it could be anything. It could be a compute function, it could be an email address, it could be a whole web server. Now, some of the applications for SNS would be to publish information in a workspace to customers, to a specific group of people, such as only the shareholders, and to multiple groups of people, such as the marketing team and the finance team, but not the information team or the HR or legal teams. Now let's talk about SQS. SQS is a service in which a user can send, receive, and store messages between virtual components within an application without losing any of the messages that were sent in between. It also ensures that they came in the order that they were sent in, which is very important, especially if you're doing a process in which the order of the steps that you take is crucial. Now, the user on the receiving end will have to receive the message, have to process the message, and then delete the message from the queue. And what this can look like in a real life situation, let's say you're asking for a burger in a restaurant. So what'll happen is you'll make an order to the cashier, and then the cashier sends the data, which inputs the order into the queue. Now the queue is ready. Now the cook will see the order, they'll receive the order. Then they have to process that order, which means they're gonna make your burger. And then finally, when they're done with your burger, they're gonna mark that order as complete and they're gonna remove it from the queue, which is basically just deleting the order from the queue. That's basically how SNS and SQS works. Now let's look at the computing side of this video. Now, as I said, we're not going to be talking about EC2. Those were already covered in previous videos. I'll put the link in the description. The services that we're going to be talking about today are Lambda and Fargate. We're going to go pretty briefly over these because they're not super important. Most of the time, you'll be worrying about EC2 computations, but it's important to know that these have their own functionalities. Now, both AWS Lambda and Fargate are serverless, which means you don't need to provision servers beforehand. You just put in your code and you get it computed. But you only pay for the compute time that you use. And for Lambda, the code really goes only when an event triggers it, which you can set. You can set the trigger to be either a button that you press. It can be when a certain server is at capacity. It can be when, you know, a certain server shuts down, or when somebody logs on to their system. You can set an event to trigger this function to compute a certain code and apply it. And since it doesn't need you to provision servers, you can focus more time on actual product development and innovation rather than maintaining these servers such as you would with EC2 instances. This just adds a component of agility in your, you know, entire application. Now let's talk about Fargate. It's very similar. The only difference is it's not quite event-based. It's just a serverless compute engine. It's also only for containerized applications, which we'll be looking into the next video. There's no need to provision servers, and once again, you only pay for the compute time that you need. It only works for containerized applications once again, and we're going to be talking about that in the coming days. Now, thank you for watching. In this video, we covered simple notification service, simple queue service, we covered Lambda functions, and we covered Fargate. In the next video, we're going to be focusing on containerized applications. It's a pretty important video. It's going to be pretty in-depth because questions like these come pretty frequently on the exams. So thank you for watching this video. Please like and subscribe and have a wonderful day. Thank you.